Hi everyone, welcome back to ASFC Chemistry. I'm going to go through with you very briefly here the Carn-Ingle Prelog rules of assigning priority when we're looking at EZ isomerism, and explain the difference between this and cis-trans. So we've got two molecules at the top that are stereoisomers of each other. This means they have the same structures, but the atoms are arranged differently in the space provided. So what we can see is, since the double bond is non-rotational, we can see that the position of some high priority groups around each carbon, so one at a time, is different. If we start on this structure just here, what we've got, if we identify all of our atomic numbers of the direct atom that is bonded to each carbon in the double bond, what we can see is that we are concerning ourselves with the 1 of hydrogen, 9 of fluorine on this side, and the 6 of the carbon. Now, I can't stress enough that the CIP rules, the Carn-Ingle Prelog rules, assign priority based on the atomic number. So for carbon, we look at the 6, not the 12. It's very easy to call it the AR, and we know that AR would actually be the 12. So remember, this is brand new to the specification, and we don't want to be making a silly mistake like that, because it would cost us a mark in a written explanation of how priority is assigned using these guidelines. Going back to our molecule then, what we can see is that because on each carbon, the larger atomic number, group or atom, is above and below, we would describe this as the E isomer of this particular alkene. On the other side over here, if we label up the same atomic numbers once again, we can see that on the other side, we've got the two high priority fluorines with their larger atomic number values. Both of these are on the same side. So we've got top side and underside. And since they're both on the top side, or the same side, or the same side, cheesy, I know, but it works, this is the Z isomer just there. So just to repeat, we assign priority based on the atomic number, and we can see here on each of our structures, when we look at each carbon one at a time, that the high priority groups are either above, below, which makes it E, or on the same side, both above or both below, it wouldn't have mattered, and that would have made this one Z. So how does this differ from the cis-trans isomerism? Well, for cis-trans isomerism, it actually has nothing to do with assigning priority. Take these two stereoisomers down here, for instance. Now, normally what we do is we'd assign priority and look at the 35 atomic number value of the bromines and say, well, this is the E isomer, just like we saw above with the position of the fluorines. But since we're actually trying to assign cis-trans, we look at the hydrogens. And what that means is, in order to show cis-trans isomerism as well as EZ, we need to make sure that each carbon in the double bond is bonded to a hydrogen. So this not only shows the trans, for the reason that I've circled, but it still maintains the fact that it would show the E because of the high priority, large atomic number value bromine groups. What that means is, if we look at this structure up here, each carbon isn't bonded to a hydrogen. So for instance here, there's no direct hydrogen here on the right-hand carbon. Therefore, this structure can be E, but can't be trans, whereas this one can be trans and therefore automatically E as well. So the rule is, we can show E whenever there is trans, but we can't always show trans where there is E. Looking down at this structure then, just to finish us up, we look at the position of our two hydrogens, and I've gone for both below this time, and this would be cis for the positioning of the hydrogens, whereas it would be Z because of the positioning of the bromines, which are classed as high priority. So what happens, or how does something not show cis-trans or EZ? Well, we've got an example on the right-hand side, just over here. And if we look at this carbon is bonded to two of the same atom. So whilst it does have two hydrogens throughout this, because the hydrogens are both on the same carbon, it cannot show cis-trans. And furthermore, on the other side, you don't have to have both sides with this, but on the other side, what I have done as well is I've shown you how it's got two of the same group on this side. So it can't show cis-trans because the hydrogens are both on the same carbon, and more to the point, it wouldn't show EZ either because both carbons are bonded to two of the same atom or group. It only takes one of them to be bonded to two of the same atom or group, though, to actually break this criteria for cis-trans. I hope that clears up some of the small pointers about EZ isomerism and how it can differ but also be similar to cis-trans. Keep watching the rest of the playlist for more videos, and happy revising.